Last time we talked about arithmetic sequences, and today we're going to look at what are geometric sequences. With arithmetic sequences from last class, that was where the terms progressed by either adding or subtracting a constant number. Geometric sequences differ because they are for multiplying by a certain number for each. So what is a geometric sequence? You'll either hear it as a geometric sequence or you might hear it as a geometric progression. So this is a sequence where each term differs from the previous by multiplying by a constant. So a geometric sequence or progression is a sequence where each term differs from the previous by multiplying by the same non-zero constant. So some examples of geometric sequences would be 0.5, 1, 2, 4, and 8. If we look at this, to go from here to here, you would multiply by 2. Same there, and that pattern continues. Okay, sometimes like this example, it's not too bad to pick up on. We know 2 times 2 is 4. We know 4 times 2 is 8. Other times it can be a little bit maybe trickier to pick up on. Especially on an example like this where the numbers are getting smaller. So we have to ask ourselves, what would I multiply 162 by to get 54? A way to figure this out without having to just know. Just like, oh yeah, I know what you multiply it by, done. Like we did up here, where double of 1 is 2 and double of 2 is 4, where we can see it. If you can't necessarily see it, then we're going to take this term divided by the previous. So we do 54 divided by 162, which is going to, put my calculator under here so you can see it. So 54 divided by 162 simplifies to 0.3 repeating. It'd be good to have this as a fraction so we don't have to round that. And we press math, enter, enter. Changes it back into a fraction of 1/3. So 1/3. So to get from 162 to 54, you multiply by 1/3. To check to make sure that that continues, 54 times 1/3 is 18. Okay, 18 times 1/3 is 6, and 6 times 1/3 is 2. Multiplying by 1/3 is the same thing as dividing by 3. But we always write the multiplication number because whenever we use our formula, it's very important that we use this multiplication number, the 1/3. We don't use the divide by 3 piece. Just like with arithmetic sequences, we're going to have to pick out different pieces. So we have the terminology u sub 1, which stands for our first term. So the first term of this is 0.5. With arithmetic, we call our common difference d, but with geometric, we call our common ratio r. So that's the number that you would multiply by, in this case, 2. So down here, our u sub 1, our first term is 162, and our r is the 1/3. Once again, if you have trouble finding the r value, then you take the second term divided by the first, and it should spit out that r value for you, and that should remain constant throughout the entire question. Just to kind of put this into, like, solidify it a little bit, a sequence is geometric if you can take the further term, the n plus 1, so that would be this one, divided by the n, the original. And you should be able to do that all the way through. Like you should do 2 divided by 6, 6 divided by 18. It's saying as long as those are always the same, as long as it's constant throughout, as long as you can take the second divided by the one right before and it's constant, then it's geometric. So, like, I'll go back to 1. 1 divided by 0.5 is 2. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is also 2. So that's that common ratio throughout. If you can do that, then you know you have a geometric sequence. All right, next thing. If A, B, and C are consecutive, meaning in the same order, in that order, A, B, C, are consecutive terms in a geometric sequence, then you should be able to take the one that's further ahead divided by the previous, B over A, and it should equal that throughout the entire sequence. So if I do C divided by the one just previous of it, those should be equivalent. They should both be equal to your common ratio of R. So we had with arithmetic, we had a general term for our sequence. We're going to have the same thing for geometric, and that is also going to be available to you in your IB booklet. So here's the booklet. I guess I'll kind of keep track. We've done percent error. We did this for arithmetic. We'll come back to this one next time. And today we're going to use this one for geometric. So I'm going to copy that down out of my booklet and talk about what each thing means. So this is the general term formula. And this is in your booklet. You do not have to memorize it, but you need to know how to use it. U sub n equals U sub 1 times R to the n minus 1. A lot of the stuff means the same thing it did in our previous. So U sub n is the value of the nth term. U sub 1 is our first term. R is the common ratio. And n is the term number. So let's look at an example of what we can do with this. I do not have room below, so an example. Here's our geometric sequence. For part A, we're going to have multiple parts here. Show it is geometric. So in order to show it's geometric, we have to show that there's a common ratio. Up above, we said right here that these have to be equivalent. So if you divide the further term by the one previous to it, then you should get, it should be equivalent. So let's try that. 4 divided by 8. So I took this divided by that is 1/2. Now we go to the next one. 2 divided by 4, also 1/2. If you use decimals, that's completely fine. 1 divided by 2, well, that's definitely 1/2. And then 0.5 divided by 1 is also 1/2. Once again, if you do this in your calculator and you use your decimals, that's fine, especially in this case because your decimal's a nice, easy decimal, right? 4 divided by 8 is 0.5. 2 divided by 4, 0.5. Okay? So those are consistent, showing that, yes, it is geometric. I'll write my main pieces of information. My common ratio, R, is 1/2. And my first term is 8. There's my first term. Okay, part B. Let's write the general term. Your general term always starts out with U sub n. And in your general term, you should have the n left. So you have a place to plug in if you wanted to find other terms. So my general term for geometric, we look up here at the orange that I wrote. It starts out with your first term, 8 times my ratio. I'm going to put that in parentheses since it is a fraction, 1/2, to the n minus 1 power. Done. That's all we do. Okay, that is our general term. Part C, let's find the 12th term. Since we have our general term already written, in order to find the 12th term, we just plug in 12 for n. So u sub 12 is equal to 8 times 1/2 to the 12 minus 1. And here we go. 8 times parentheses 1/2 to the 12 minus 1. When I do this, if your calculator doesn't separate your exponent like that, then you need to make sure to put this in parentheses. If it does separate your exponent, you're fine. 12 minus 1. Okay? If I would recommend, if you're more relying on your calculator here, we don't multiply the 8 times the half because we have to do the exponent first. So if you wanted to break it down, you could do 12 minus 1 is 11, 1/2 to the 11, and whatever that is, take that times 8. So this calculator says our 12th term is 0.0039, and then the 6 here would round my 0 up to a 1 in order to get to 3 sig figs. I like to always double check, so if you forget how to use this formula, let's say like on your actual IB test, and you're like, oh man, I know how to solve this problem, but I forget how to use the formula, then go back to the original. This is my first term, second term, third term, fourth, fifth. So you're already at the fifth term, so 0.5 times, we said it's multiplying by a common ratio of 1/2 each time. Enter. That would be my sixth term times 1/2. So that's 6, 7, 8, 9, 10, 11, 12. And that's exactly what we got here. So, especially if it's something like 12th term, that's not going to take you very long. If it's like 100th term, might take you a little while, but still, if you can get to the right answer, that's some points you can get on your IB test that if you forgot how to use the formula, you would have missed. Okay, let's do another question. Example. K minus 1, 2k, and 21 minus k are consecutive terms in a geometric sequence. Find k. So we need to set up an equation involving these little pieces that they gave us in order to solve for k. We have this piece from above, this. So this is a little equation that we can use. B is that middle term, so you did B divided by A is equal to C divided by B. We can do the same thing down here. So you think about like this is the first, the second, and the third. My A, my B, and my C in that order. Then we do our B, 2k, divided by k minus 1 equals. Then we do C divided by B, 21 minus k over 2k. That's a lot of k's. You can solve this by hand, but ick. Okay, this is ick. A lot of k's in different places. We've got fractions on both sides. So in the last couple sections, you learned how to solve equations without having to do all the algebra. We can instead use our graphing calculator. I kind of would like to get it out of fractions first. You don't have to, but I think it makes it look a little nicer here in a second. So if you have a fraction equal to a fraction, you can cross multiply in order to solve. So 2k times k is 4k squared. And then we do k minus 1 times 21 minus k. In my graphing calculator, I'm going to type both of these into y equals and figure out where they're equivalent to each other. So y equals, all sorts of crazy stuff in here. Okay. So I'm going to type in 4x squared, and then on the next line, x minus 1 in parentheses, and then 21 minus x. So I typed in the left side of my equation and the right side of my equation. We click graph. We're trying to figure out where these intersect. Okay, there's the first and there's the second. So we can always go to our table and see if anything shows up there. There's one. So they intersect at x equals 3 because my y value in both cases is 36. So that's at least one answer. K equals 3. I think there's going to be another one. So let's go back to our calculator, or graph. It looks like it's intersect, so 3 would be 1, 2, 3 all the way over here, but it really looks like maybe right in there, because that line's coming up and intersecting that. So I'm going to go zoom. I'm going to zoom in, and I'm going to get my cursor up there where it seems like maybe that's where it's intersecting, like right in here. Let's see if anything shows up. If not, we'll try some other strategies. Oh, maybe up there? Let's see if it'll give it to us. Second, calculate, intersect, enter, enter, enter. Yay, it did, okay? So you kind of have to play around with it until you can figure out where it intersects, but it does intersect at 1.4, and so that's our other solution. Those are the two answers to this. In order to check to see if they work, sometimes they'll work. They should always work. Let's take a look and make sure. So I'm going to start by checking the 3. These are my 3 terms that are supposedly consecutive terms in a geometric sequence. So K is 3, 3 minus 1 is 2, 2 times 3 is 6, and 21 minus 3 is 18. Okay, so that would be multiplying by 3, multiplying by 3. So this one checks out. If I check my other one, so same here, but we're going to check this one. So 1.4 minus 1 is 0.4. 2 times 1.4 is 2.8. And 21 minus 1.4 is 19.6. That's icky. Let's see if it has a common ratio. 2.8 divided by 0.4. And 19.6 divided by 2.8. Oh, no, I multiplied. I pressed multiply, I meant to press divide. Yay, okay. So that's multiplying by 7. So to get from here to here, times 7, there to there, times 7, both of those values end up producing geometric sequences. Okay, last example here with geometric sequences. So I'm going to give you some information. We have a geometric sequence. U sub 2 is negative 6, and U sub 5 is 162. So I'm going to do the same thing I did with arithmetic as far as drawing this out. So first term, second term, third term, fourth term, fifth term, maybe sixth term. I know my second term is negative 6. Second, third, fourth, fifth term is 162. So we're trying to figure out the general form. So find the general term. So with arithmetic, I went like this. With arithmetic, you have to add each time. With geometric, you have to multiply. So we have to multiply, multiply, multiply. So I have to multiply negative 6 by something, my R value, 3 times in order to get to 162. So to get from here to here, I would multiply by R, then by R, and then by R, and I would finally get there. So to write an equation that represents this is we would say negative 6 times R times R times R is equal to 162. What can I multiply negative 6 by 3 times to give me 162? R times R times R is R cubed. And that's the icky equation. We have an exponent of 3. You might remember how to deal with that from Algebra 1. You might not. So let's use our calculator to help us solve. I'm going to start out in my y equals. I'm going to type in the left side of my equation and then the right. The left side is negative 6x to the third. It just deleted it. X to the third. And the other side is 162. That's big, so I know I'm going to have to do some zooming out probably. And I'm still zoomed in from the other one. So go zoom 6, comes back to here. Alright, zoom out. I think I have to zoom out more. I'm going to look at my table first. Let's see if there's anything there. looks like it'd be this way. Oh, right there. Okay, so it's saying r would need to be -3. Okay, we can always check and see if that works. In fact, that'll be the only place it intersects. And let's double check and see if that works. So up here, to get to my next term, -6 times -3 is 18. So I'll fill in these blanks. Times -6 gives me -108. Times why am I multiplying by -6? -3, I'm sorry. So -6 times -3 is 18. 18 times -3 is -54 times -3, 162. So that works. So a ratio of -3 does work to get from one to the other. The other thing we need for the general term is our first term. So if to go forward, we multiply by -3. To go backwards, we divide by -3. So -6 divided by -3 is 2. Which will be my first term. Write the general term. This is what's given to you in your IB formula book. We're going to leave our use of n since it's our general term. We want to leave the n. Our first term we said was 2. We found our common ratio to be -3. We put that in parentheses to keep the negative with it. And we always have an n in our answer. So this is the general term of this sequence. Alright, I'm going to stop here for now. Thanks for watching, and as always, stop me if you need some help.